Hello guys, so in this video we will discuss the longest increasing subsequence problem, which is a medium type problem on the LeetCode. So we have given an example whose output is 4. So let's discuss the example and approach to solve this problem. So what are the possible increasing subsequence here is we can have 10, then 101 or 10, 18. It will be of length 2, or we can have 9, 101 or 9, 18. It will be also of length 2, or we can have 2, 5, 7, 101 or 2, 5, 7, 18, or we can have 5, 7, 101 or we can have 5, 7, 18. So there are a lot of increasing subsequence possible, but we have to talk about the longest increasing subsequence. So longest increasing subsequence is of length 4 only. Okay, so how we will find out the solution for this problem? So one brute force approach is to calculate all the subsequence and then find the longest increasing subsequence among this element. So what are the possible subsequence here? Uh, we have given we have given 10, 9, 2, 5, 3, 7, 101 and 18. Every element is having the two choices, either occur in the subsequence or not. Okay, so everyone is having the two choice. So total number of subsequence will be 2 raised to power. We have 8 elements, so it will be 2 raised to power n. So if we have given the n element in our array, so it total subsequence possible is order of 2 raised to power n, and then we have to calculate the uh, longest increasing subsequence among these 2 raised to power n subsequence. So definitely it is a very bad approach to solve this problem because it is taking the exponential time. So whenever we talk about the all the possible sequence, then we one thing comes one thing that should come into our mind is DP, dynamic programming. So also for before applying the dynamic programming, we should also follow the optimal substructure property. So let's say if for example up to 7, if we talk about this array only, so what was our longest increasing subsequence? So longest increasing subsequence was 237 or 257. Okay, 237 or 257. But if we add two more element 101 and 18, then our longest increasing subsequence can be 101 or 237 18. So previously it was our solution. When we added more element, then this solution is becoming is taking part of our larger problem. Okay, this solution is added up to a larger problem. So definitely this solution is repeating. So here optimal substructure property is followed. So we can apply the dynamic programming here. So how we can apply the dynamic programming here is, so what we will do is we will make an array. We will make an array of length 8 because we have given the 8 element. Okay, and every index of the array will tell me that if element which is present at the index 1 or any I if it would be the part of my longest increasing subsequence, that what would be the length of that subsequence. Okay, once I will discuss the example, you will it will be understood. So let's say we read 10, then we will find out that we will check if 10 is in our increasing subsequence. Then we will what will be happen if 10 will be in our longest increasing subsequence. Then all the element in the subsequence that we have currently now, uh, the left of the 10 means the element which is present on the left, which are small, the elements which are smaller than 10, that element can only be present in our increasing subsequence. Because if 10 will be the part of our increasing subsequence, then all the element which will be present in our current increasing subsequence would be smaller than 10. So we will check the all the smaller element than 10, and whenever we will find the smaller element, then we will check what is the maximum length of the longest increasing subsequence by considering that element. And we are including 10, then the maximum length will become plus 1. Okay, uh, don't worry, uh, when I will try run the code, then you will understood better. So we are checking 10. So currently we do not have any element to the left of the 10. So if it will make our increasing subsequence, so it will be of length 1 only. So we will place 1 here. Then we will come to 9. Then we will check any element which is smaller than 9. So we have 10 only to the left of 9. So and 10 is not smaller than 9. So if 10 will be our longest increasing subsequence, then it will be of length 1 only, because it can make the increasing subsequence only with the smaller element than 9. But we do not have any smaller element. So if we want to make the increasing subsequence including 9, so it will be of length 1 only. So similarly, if we talk about 2, then we do not have any element which is smaller than 2, so it will be of length 1. Then we will check 5, then we will find that 2 is smaller than 5, and with 2 we can make the increasing subsequence of the length 1. So if we will add 5, we have increasing subsequence as 2, and if we will add 5, then we can make the increasing subsequence of length 2. Whatever is the longer subsequence still here, plus 1 will be made by including 5. So it will be 2. Okay. Similarly, if it then we will check 3. Then element is smaller than 3 is 2. So we will say that what is the maximum length by including 2? By including 2 is 1. So when we will add 3 also, then it will become 2. Okay. Then 7, we will come to the 7. Then we have 3, 5, 2 is smaller than 7. So we will find out the what will be the maximum of these 3. So uh, by including 3 in our increasing subsequence, we can make the longest increasing subsequence of length 2. By including 5, we can make the increasing subsequence of length 2. By 2, we can make the increasing subsequence of length 1. Okay. So what is the maximum among these 3? This is 2. So either we can uh, take the increasing subsequence up to 5 and then 7, or we can take the increasing subsequence till 3 and then 7. So then it will become 2 plus 1, 3. Similarly, 101, we have all the element to the left of it is smaller than it. So we will we will then see that 3 is the greatest among all the elements which are smaller than 101. So what will be the longest increasing subsequence? If we will include 101, it will become 4. 3 plus 1 will become 4. Similarly, 18. So we have a smaller element, lots of smaller element than 18, and maximum length of the increasing subsequence by considering all these element is 3. So we can add plus 1 and we can say the longest increasing subsequence possible is 4 by including 18. So we get the maximum answer as 4 among this array. So we can print the 4. So what would be the time complexity of this approach? What we are doing is we are going from left to right, and it will take order of n for every element we are traversing to the left of the element. For example, if we are at 10, then we will check all the left elements of the 10. If we are at 9, then we will check all the elements which are present on the left of it. And then similarly 2, we will check 10, 9. Then at 5, we will check 10, 9, 2. So its time complexity will be order of n square. Okay. So how we can further optimize this time complexity? This is fine that you can find out the time complexity, find out the longest increasing subsequence in order of n square, uh, whereas in the brute force, if it was taking 2 raised to power n time, so we have decreased so much time complexity. So what can be the more optimized way to solve this problem is, so let's discuss the third approach. It was the second approach, and first approach was the brute force, and let's discuss the third approach. So in third approach, what we can do is, let me write the array again: 10, 9, 2, 5, 3, 7, 1, 0, 1, and then 8. Okay, so what we will do is, we will take one array. We will take one array. Okay, and what we will do is, we will put the first element of this the given array to our new array, and we will say our length currently, our maximum increasing subsequence length is 1. Okay, and we will run the loop from here. Then we will check that we have 9. Then what we will do is, we will compare 9 with our element present in this new array. We have 10. So if 10 would be, uh, this array is representing our longest increasing subsequence. So initially we have the longest increasing subsequence is 10, which is of length 1. Okay. So if we want to make the longest increasing subsequence including 9, so it is obvious that 10 then 9, it will not be the longest increasing subsequence. So what we have to do is, we have to replace the 10 with 9 to make the longest increasing subsequence including 9. So we will say that it would be 9. Okay, and length will remain 1 because we have the longest increasing subsequence of length 1 only. So then we will go to the 2. Then we will check if 2 would be in our longest increasing subsequence, then where should it present in our subsequence? So we have 9. So 2 definitely is not cannot come after 9. It cannot occur before 9 also, because it will not be the subsequence, because in our original array 9 is coming first, is appearing first. So we cannot write it like this. So if we want to make the longest increasing subsequence including 2, then what we have to do is we will replace the 9 with 2. We will say that it is 2, and the longest increasing subsequence is still length 1. Then we will come to 5. Then we will compare 5 with 2. Then we will check, yeah, 5 is greater than 2. So 5 can make the increasing subsequence with 2. So what we will do is, uh, we have indexing like this. So what we will do is we will put the 5 to the uh, 1. So 5 will become here and we will increase the length by 1, and now it will become 2. So it is showing that we have currently longest increasing subsequence as 2 5, which is of length 2. Okay, then we will come here 3. So if 3 would be in our 3 would be in our longest increasing subsequence, so where should it appear in the increasing subsequence? So it can occur only after 2. So what we will do is, what we will do is we will replace the 5 with 3. Then we will again uh, check 7. If 7 is to be occur in the longest increasing subsequence, then it can occur after 3. So what we will do is we will place the 7 at index 2. So it will come here and we will increase the length by 1. Now it will become 3. So okay, now we have the long increasing subsequence as 3. So now we will check again 101. So 101 can occur after 7. So what we will do is we will place the 101 at the index 3. So 101 will be placed here and will increase the length by 1. Now it will become 4. Now we will check 18. Now 18 is not greater than 101. So if 18 will be in our longest increasing subsequence, then where should it place? So it should place at the index 3 where 101 is present. So we will replace this 101 with 8, and we will, okay, yeah. So we at last we have end up with all the elements. So at last we got that length is 4. So we got the maximum or the longest increasing subsequence of length 4, and we also have our longest increasing subsequence array. So what is the time complexity for this approach? The time complexity for this approach is order of n log n. How? Because we are traversing through one every element, so it will take order of n. And we are comparing the element with the last element which is present in our array, so it will take order of n. In the worst case, if let's say for example, uh, we have increasing subsequence s 2 3 8 or 6 8 like this. Okay, and now we have to insert the 5. Now we want that 5 should be in our increasing subsequence. So what we are doing is we know that this is representing the increasing subsequence. So it is monotonically increasing fashion, in monotonically increasing fashion. That is, it is in sorted manner. So we can find the right index of the 5 by using the binary search, and binary search can find the index of the 5 in log n time. So we can find that 5 should be present here. So instead of checking all the element iteratively, what we can do is we can run the binary search and we can find the right index for 5 in order of n time. So it will take n log n time. So we have given the this syntax. So let's write the code. So what we will do is we will find out the length of the given array nums. So it will be nums dot size. Okay. And what we will do, we will create one new array. We will create the vector which will store the longest increasing subsequence that we have found. So it will be of line length n, because in the worst case, for example, if we have given the array in the increasing order, so in that case our longest increasing subsequence will be of length n, which will be the size of the array itself. So it can be, in the worst case, our maximum or longest increasing subsequence can be of length n. So, and what we will do is we will put the first element of our array to the lo- we have given an array of nums. Okay, so if we will talk, we will read 10, then 10 will always make the longest increasing subsequence of length 1, because there is nothing present to the left of it. So it can make the length longest increasing subsequence of length 1 with itself. So we will place the 10 to our longest increasing subsequence array. Okay, or let's say we name it as LIS, longest increasing subsequence array. Okay, okay, so we have put the 10 to our, uh, we have we have to put the first element, so it will be nums of I. Okay, now what we will do, we will then iterate over the remaining element, and we will check if the element which is present at the index I is greater than the element which is present at the end of our longest increasing subsequence. So we have to check if this is the case, and we also have to take one variable as int length, which will be 1, because initially we have increasing subsequence of length 1. So we will check if it is if the element present at the index I is greater than the element which is present at the end of our longest increasing subsequence. So it end index will be length of length minus 1. So it will be the case, then what we can do is we can append the nums of I to the end of the longest increasing subsequence. So we can simply put the uh, lis l nums of I. Okay, and we can increase the length by 1, because now length of increasing subsequence will be increased by 1. And in else case, what we can do is we can find out the index of nums of I. If we want to count the nums of I in our longest increasing subsequence, then what should be the index of right index for that element? So we can run the binary search for it. So we will write the code of the binary search, or we can uh, uh, and in which array we want to apply the binary search. We are the array in which we are storing the longest increasing subsequence. So we will pass lis array, and whose starting index is 0 and the end index is length minus 1, and element that we want to search is nums of I. Okay, so whatever the index we get, it will be the index where that nums of I should be present. So what we will do is will simply put the this nums of I at index that we got. So we will say that lis idx is equals to nums of I. Okay, and at last what we can do is whatever will be the longest increasing subsequence length, so it will be stored in our length variable. So we can simply return length, And let's make the binary search function. So it will return the index. So int, it will be int binary search, and it will store, or it will receive the vector of int, which will be lis, and starting index is I, or then int j, then got the element. Okay, then what we will do is uh, we will find out the mid index, or we will say while j is greater than I. What we will do is we will find out the mid index. So we will say I j minus I upon 2 plus, and we will say if the element which is present at the mid position is greater than or equals to the element, so our j will become mid, and if it is smaller, then our I will become mid plus 1. Okay, if we don't know binary search, so I have covered the binary search video in my playlist, so you can watch the binary search code from there, and then here we can simply return j. So this code should work fine. So let's run the code. So let's submit the code now. So this is accepted. So I hope you understood the problem, and the runtime we got is 59 milliseconds. Okay, so I hope that you understood the concept of this problem.